And here we are with Module 4 Class Notes Example 1. We're taking a look at rational functions and graphing rational functions. If you have not done so yet, please check out the Example 0 where I introduce the characteristics of rational functions in this Module 4 video series. And so assuming that you have that information, I'm going to go from there and we're going to try to sketch the graph of this rational function by first identifying the characteristics and properties like domain, intercepts, and asymptotes. So here we are looking at the domain of this function, and we know for domain restrictions for fractions we can't divide by 0. So x plus 2 cannot be 0, meaning x cannot be negative 2, subtracting 2 on both sides there. So our domain is everything but negative 2. That is everything from negative infinity to infinity, but we have to exclude negative 2, and this is what that looks like in interval notation. Next up, we'll look at the intercepts of this graph, the intercepts, both x-intercepts and y-intercepts. Here, the y-intercept, just like any other function, we find y-intercept by plugging in 0 for x. And find f of 0, replacing x by 0, we get 0 minus 1 over 0 plus 2, that's negative 1/2. So the y value is negative 1/2. When we have an input of 0, the output is negative 1/2. We've got the point 0 comma negative 1/2 as our y-intercept. For x-intercepts, we let y equal 0. In other words, we let the output be 0, and we solve for x there. That's not terribly difficult to do if we first multiply both sides by x plus 2 and realize that anything times 0 is 0. Then we end up with just x minus 1 equals 0. Add 1 to both sides, we get x equals 1. Let me slow that down a bit and say from here, we clear the fractions by multiplying both sides by x plus 2. It's just that when we multiply by x plus 2, times 0 is still 0. And so all we have left is the numerator equal to 0. And in fact, that happens every time, so that as a rule, we can say that finding the x-intercepts by setting y equal to 0, we can ignore the denominator, not because it's magic, but because multiplying the denominator by 0 will always give you 0. So we can always ignore the denominator when looking for x-intercepts and set the numerator equal to 0. Find your x values. In this case, we get x equals 1, and so an x value of 1 corresponds to a y value of 0, and the point 1 comma 0 is our x-intercept. So now we've got a couple of points on the graph, but we still need to find asymptotes. So let's look for our asymptotes, vertical asymptotes and horizontal asymptotes. Our vertical asymptote will be found by, according to that domain restriction, x plus 2 can't be 0, so that line where x plus 2 equals 0, or that line where x equals negative 2, that vertical line, that's going to be your vertical asymptote, a line that the function is approaching but never quite crossing that x value of negative 2, so x equals negative 2. And the horizontal asymptote, make sure that you look in your text, look at your pre-class work from your textbook reading, and note that you've got some rules for horizontal asymptotes that depend on the degree of the numerator versus the degree of the denominator. In this case, both degrees are 1, so we have the numerator degree equal to the degree of the denominator. And in that case, we take the fraction of the leading coefficients, 1 over 1. Y equals 1 over 1, y equals 1 is the equation of the horizontal asymptote there. So we've got a vertical asymptote at x equals negative 2, a horizontal asymptote at y equals 1. We can start putting that information together here with a vertical asymptote at x equals negative 2, a horizontal asymptote at y equals 1, the points 1 comma 0 for my x-intercept, and 0 comma negative 1/2 for my y-intercept, and connect the dots and approach the asymptotes, and there's my curve, or at least one branch of my curve. There should be another branch somewhere over here on the left side of the asymptote. It's looking a little empty over here, looking a little lonely. There should be a branch of my curve on this side as well, and there is. We can't see it yet because we don't have any points over here, but that's when we go back to the function and go pick additional points, or at least one additional point. And we can choose any x value we want. We should probably choose an x value that is over here in the region that I'm considering, like this x value of -3. So I'm going to go back and plug that x value back into my function to find just another point on the graph to help me fill in the sketch of the graph here. Plugging -3 back in for my additional point, I get -3 minus 1 over -3 plus 2. That's -4 over -1. That's +4. So an input of -3 gives me an output of +4. We plot that point on the graph, -3, +4, and then let the function curve toward the asymptotes, the horizontal asymptote and the vertical asymptote, and we have the other curve of our graph, the other branch of our graph. So this then represents a sketch of the graph of this rational function.